All right, hey folks, I want to talk to you today about one powerful tool inside of QGIS that is often overlooked, and sometimes people end up having to pay for a tool like this. But we are going to learn about reprojection today, and I'm going to show you an example of what that looks like. It can be done in QGIS for free, so let's discuss. First thing that we have to understand is why would we want to reproject? When we take images off of our drone, they're captured in WGS84. That's a geographic or a geodetic datum, and it's using latitude and longitude, right? We're familiar with seeing that ellipsoidal height. But one caveat real quick is we're always going to keep our X, Y, and our Z as separate. They're not always tied to each other. So in this instance, we're going to throw the Z out completely, and we're only going to focus on the XY coordinates here. So we're just trying to get from our XY coordinates and reprojected into a local datum. So when the map comes out of our software, it comes out as a UTM 14 North. So that's a WGS84 datum that has been flattened or projected down to a flat surface. And so the standardized projection for our zone is UTM 14 North. And so what we'd like to do is take that UTM 14 North and then reproject it into our localized datum, which is the NAD83 State Plane. And for us here in North Texas, it's 4202. So I'm going to show you how to do that here in QGIS. First thing we need to do is go grab our RGB. So this is our ortho, and we want to first establish what kind of projection this is in. So we're just going to hit properties, and if you click source, you'll see that we have it in EPSG 32614 WGS84 UTM Zone 14 North. So that is in WGS84 14 North as it sits right now. And what we'd like to do is get that into our NAD83. So we have already established a base at this location. So let me quickly show you what this looks like. We established a base, and then we ran it through OPUS, and we got a solution back, okay? And so looking at our OPUS solution, and you don't understand the OPUS solutions completely, I explained that in another video, but here we have our latitude and our longitude, okay? And then we have the ellipsoidal height. Again, we're not going to be working with height. And then the ortho height, orthometric height. And that is the difference in the geoid. And then we have down here our UTM coordinates, okay? And so the UTM zone 14, it's two columns here. Then you have your state plane coordinates, but they're in meters. So this right here is our UTM coordinate for our Y. This is for our X. And then we have a convergence and a scale factor. Over here, we have our state plane coordinates in meters and then our X in meters. So if you're familiar, state plane typically is not expressed in meters. In most states, here in Texas, we use the US survey foot. So we would have to change these over to US survey foot. But like I mentioned in the OPUS video, if you ask for the extended, you go all the way down here, they're going to give you the state plane coordinates in US survey feet. And so these are our coordinates X, Y in US survey feet. And we'll come back to those, okay? So what I'd like to do is plot to kind of prove that we are in fact reprojecting. I'm going to plot a point at this UTM coordinates of X and Y. So what we've done is we've already created a file. It's a CSV file. I'll show you over here. And it is our demo point. And here is the UTM 14 North. So those are our coordinates. This is in meters, elevation in meters. So that's an ellipsoid. But here's our northing and our easting, all right? And then in QGIS, all we're going to do is we're going to plot this or add a layer. So we go to layer, add layer, and this is a delimited text layer. And so we're going to go and find that file. We're making sure to grab our UTM 14 North. I also created one in NAD83 that will add layer, but here's our 14 North. And then here we're telling it the geometry definition. Our X field is the easting field, easting column. Our Y field is the northing. We could put our Z field here in his elevation, but it's not really going to do anything. And then we need to define what the coordinate reference system is for the CSV file that we're loading, which is our project coordinate system of 32614 WGS84 or UTM 14 North. So when we hit add, that plots that point. And what I'm going to do is kind of change the symbology of the point so that it's a little easier for us to see. And if you notice, it's way down here in the corner. So we've established a base way down here in the corner. I'll zoom in real quick and we can see that it's established right there. All right. So let's zoom out real quick and let's run this reprojection. Okay. So the first thing we need to do is select the layer that we'd like to reproject. And we get to this in a couple of different ways. We have our processing toolbox, which opens on the right over here. If you lose it, just come up here and grab processing and then toolbox. Or you can also get to this tool via the raster. Processing toolbox is a great way, once you get very familiar with the program, that you can just type in a tool that you want to use and it'll pop up there. But this, because we are messing with the raster, which is the RGB, we can reproject just the raster. And so we're going to come in here to raster, projections, and warp or reproject. Okay. So this is the dialog here. Again, that can be found over here if you like as well. Here we can just quickly search for warp, reproject. It's right here. All right. So first thing we're going to do is just fill in all the blanks here. So what is our input layer? Well, if you have it already selected, it should pop up here. This is our Quarry demo, and it says, what is the source of this layer? What is this layer's coordinate reference system? So your source CRS, and in our instance, it's WGS84 14 North. And then what is our target coordinate reference system? And we'd like to be in Texas North Central, or EPSG 2276. And then we can skip these other fields. Don't really have to worry about those too much. It's as simple as that. And then it's going to say, okay, when I have a reprojected file, what do you want me to do with it? We can save it to a temporary file, or we're going to save it to a file. And we're going to come to our desktop where we have our training going on. And we're going to put it right here in our reprojection. And we're going to call it reprojected ortho, and I always like to put the projection at the end of the file name, so NAD83. So now it will save this new RGB ortho in its reprojection to here. Okay, and so then we just simply click run. This process can take a minute depending on how big your file is and how how long it could take. So, but this is a great tool in QGIS that most people aren't very familiar with. And it's something that can help you kind of quickly on the fly deal with data. Now, other softwares will have this kind of built in to some extent, but really they're all basing it off of the GDAL reprojection, the warp reprojection, which is an open source tool. It's just, do you have the software to utilize it correctly? So we'll come back when this is complete. Okay, that wrapped up pretty quickly there. It only took another 10 seconds or so. And we're going to close this. Now, what it did is it added our reprojection on top of where we were before. So as we zoom in, we can see it's still a very good looking ortho, but what we do see is a black border around the edges. We could take care of that pretty quickly by going into our properties. And on the transparency, what we'd like to do is turn all of the black to a transparent color. And so what you can say is come in here, transparency band. You can go red, green, blue. I have a preset loaded here for our transparency colors. It's a style that I've saved. And these are saying red, green, blue, 0, 0, 0, 1, 1, 1. And it's designed to kind of pick up all the pixels that kind of are sort of transparent. And then you hit apply and it should remove most of those. So if also we wanted to remove all of these, let me show you another kind of a cool tool. This is a little outside of the scope what we're doing here, but since it presented itself, what you can also do is select. So it'll say add values from the display. Let me hit apply real quick. So that black comes back. We just click that button and then select the color, and it's saying, well, what you sampled was a 0, 0, 0. And then if you hit apply, bam, it changes all of it to transparent. So anyway, all right, so let's see how we can double check that this is reprojected. So what it did real quick, you'll notice if I load the UTM-14 North layer underneath it, it shows up in the same place. Okay, now why is that? Well, QGIS is doing an on-the-fly reprojection. Whenever I'm in a UTM-14 North, when I'm in one projection and I load an ortho from a different projection, it's like, hey, you know what? On the fly, I can reproject this. That's why we're seeing these two things line up in the same spot. But what it didn't do is it didn't actually change the reprojection of the file itself. It just did an on-the-fly reprojection. So in order to make sure that we're reprojecting everything correctly, or we show you, like I want a kind of a clean environment to show you, hey, this is our point. See that UTM-14 North point comes in the same spot. So all I'm going to do is just create a brand new project here in QGIS. Okay, so now we have a brand new project, and let's go grab that reprojected ortho. That is this right here. And I misspelled reproject, but we can that layer reproject. Okay, so now we're in NAD83. Let's just double check the projection source. You see it up here. We're in NAD83 Texas North Central. Okay, let's go ahead and apply our transparency. Again, so we're here, transparency. That worked out pretty well last time when we just selected that number. So what we'd like to do is let's load that base point that was in NAD83. Okay, so we're going to go select the file. Here it is. It's that Corey demo point in NAD83. And then again, it's asking what's your X field, what's your Y field, Z field. Again, we don't really need, but here we have to redefine our coordinate system, and we're going to choose Texas North Central 2276. Okay, and so we hit add. And if you look, there's the point down there. I'm going to change the symbol so it's a little easier to see. But there it is. It placed our point in the same spot. Okay, so just a reprojection. One coordinate system, we're in UTM-14 North. The other coordinate system, we're in NAD83. So remember, QGIS will do this on the fly for you, which can kind of be confusing. That's why I opened a new project and put us into the NAD83 coordinate system. But great tool. Wanted to just kind of show you what that looked like and how to do that utilizing native tools that are built into QGIS. If you have any questions, let me know.